Hi, welcome back another Sean's tutorial. This tutorial I will try to go through how the parametric surface work and what other parameters can be played with for your design. This surface is built in Grasshopper. It's being driven by two curves. I referenced it in the Grasshopper, from Rhino to Grasshopper, and then the rest is all done by Grasshopper. So how did that surface work? It just, for example, to use the vector different angle, the angle difference to the Z vector, and then the surface normal angle. Use that as the parameter to create the opening according to the surface curvature. In this tutorial, I try to run through the script just for one example how we playing with different parameters. This doesn't have to be vector. It can be different other thing. It can be color mapping. It can be radiation data. It can be lots of data. Can play with to control the opening, to control the size, to rotate, to morph everything. So it's just a bit example. I try to use that to explain. So now let's start from the scratch. So now I got my Rhino and Grasshopper opened, and I just simply drew two curves with some control point to control the curvature. So let's reference those two curves, set one curves, and then select another one, set another curve. So I can hide it, and because I can view it in the Rhino, in the Grasshopper canvas. So I got the north to make it as a surface. Sorry. Can disconnect it here. So to make it as the grid, we need to subtract the surface. Subsurface. Base surface. Anyway, we can find that parameters inside the surface. It should call isotrim. So subtract surface isotrim, and then we connect it to that. And then we also have the domain. So that means we need to create a domain for how we're gonna divide the surface. So divide surface is the components we're looking for. So also, reference the surface. Reference the surface and put it as some number sliders inside. So we have 10 by 20, and then put it back to that surface itself. It's gonna be a good habit when you don't have to be preview. Just Control Q to unpreview it, so you always have the stuff you want to see in the top. So we need to subtract the center point using the area command, and then we can use a surface closer point, surface closest point, because that central point wasn't actually 100% lay on the surface itself. So in this case, we need to have the center point to get projected to the closest surface, and then we can evaluate the surface curvature with evaluate surface itself, the component itself. So reference the UV and then use the surface previously, and then we see the different surface normal showing along each different grid. To see the width cell, we can use the vector display command to get that vector and get the normal vector surface. We can see oops, in the set value, but it's in downward, but doesn't really matter for this exercise, because we just need to evaluate the surface along the set vector. So how we're gonna do it? We use a command called .product. Use the command called .product to reference the set vector to point B to the surface normal to point A. So then we should have a bunch of lumber to showing. Yeah, it's gonna be a negative because it's facing downward. Should have a bunch of the lumber to showing. Let me see the bonds, and we can have a panel to review it. We have the minus 0.99 to 0.42, so it kind of like set it as let me fatten it, so you just got one output. It's gonna be 1 to 0, so if that's the case, we can try. Yep, we can have a negative number for the set vector, so it keeps is a positive number. And then we can use the color gradients inside output, color gradients. Maybe changing the other color to see the better result of there you go. See a better result of how the curvature difference. Since we have the bond domain, we can deconstruct it to get the start value and end value to use as the 0 to 1. Itself, it's just the 0 to 1, so it doesn't really matter. And then we apply for the parameters input T, and then we're gonna custom preview that geometry. Surface. Yeah. So now we got we don't need to preview the vector anymore. We don't need to preview the surface point anymore. So now we can see the different curvature showing, the most curvature showing in the red, and the less curvature showing in the blue. Not just smaller the grid. So how are we gonna manipulate the surface with the number we've been given? One method we could use the wireframe to extract the breadth the 4 edges. Yep. And then we kind of need to join them as each single join curves to join them to each single panels. So it will comes up to a grafted result. We may want to flatten it, so maybe let me show you the difference with the grafted result and the it's super important to understand that when you work in a data tree. So we put that sequence number in the third column, but when we flatten the data, it just have one column shows all the data has a 400 closed curve. We represent each tiles in the surface. So we could use that. We actually need to remap that number to give it some better result rather than 0.3 to 0.1. So what we're gonna do is put into the V, and then sources will be 0 to 1. We want to change the sources input to 0 to 3 to 038 to 1, interpreted to 0 to 1. Let's see how it's gonna look in. We can put scale to connect the scale factor to the mapped data, and then we need the center point, so we got the central, and then we will have the drawn the curve with with the flattened drawn the curve. Some reason you cannot scale something as a 0. It happens like this when you set up the mapping to the 0 to 1. The lowest value will be 0. So we put 0.1 to 1, so the script works fine now. So we have the small rectangle inside the big rectangle. How are we gonna do it to construct surface? We use the loft command, but before we loft it, we need to wave it because need to have a geometry. Doesn't really matter. Put it where. Put into. Let's see. Yeah, because it's good to have double check the data because we cannot running 400 simulation at once. So we can see the data structure is different. 0, 0, and 0. It's just 1, 0. So we need to flatten it, and then we connect to another flattened surface. So we kind of having the mesh like this, and we just need to simply loft it, and then because we got some error with the loft, and so in this case I may try to graph those two. So that means it doesn't have to be flattened, and that value has to be graphed to keep it as a one single structure. So let's enable it. So we kind of has the surface. That's how we want, and then we put that visualization back on to the surface. It's working. Now unpivot it. Oops, so lagging. It's really lagging. So if in this case, it's a really simple way to see that's some single parameter input, that's a graphed parameter input. So I may keep that as a graph, or I just flatten the parameter. It should be works much better now. So yeah, we kind of getting the same result for the first for the first go. I show you guys. That factor can be put something, maybe multiply thing, and then I can multiply by 0.5. If you think, I just think maybe we create better visualization. And also it has the sliders, can be control the differences. Yeah, just make it more, can be seen the difference with the color, also the opening size. I think that's it for this tutorial. Thank you very much. If you got some questions, leave me comments on the YouTube channel. I will reply to you as soon as I get the message. Thank you.